Good morning, everyone. Greetings to all. Myself as Vimal Justin, lecturer of Vimal Lecture College of Pharmacy. Today we are going to discuss about an interesting topic which is around us: errors, pharmaceutical errors. Okay, what is error? The definition of error is the difference between the true value and the measured value. While performing an experiment, the result which comes out from the experiment which differs from the accepted value, it is called error, and it is also known as absolute error. This absolute error may be negative or positive. Okay, while studying this topic, a question may arise to everyone: does this error having any serious consequences? Does it undergo patient's health into risks? The answer is yes, it have. Because if the error is large, if the error is serious, if the error is mishandled, if the error is didn't handled carefully, these errors may cause serious consequences such as health issues. So it is necessary to follow the safety measures while performing an experiment. Okay, let's briefly discuss about the sources of error. Some major sources of error in pharmaceutical analysis are described as follows. First of all, first one is human sources. If an experiment is performed by inexperienced person, the chances of error are more as compared to same experiment performed by the experienced analyst. Because the junior analyst didn't have sufficient knowledge about how to perform or how to handle the experiment without any type of errors, when see through the experiments, eliminating the error in the experiment is completely impossible, but it is possible to minimize the error. Second one is instrumental apparatus and glassware. If the instrument and the glassware as well as apparatus used in analysis is of low quality and it is uncalibrated, the chance of errors may occur. Third one is experimental conditions. If the analysis is carried out in the conditions which are unfavorable for particular experiment or analysis, the desired result will not be obtained, because some experiments which relies on particular temperature, if it did not performed on that particular temperature, the desired result will not be obtained. One, constituents used in analysis. If various constituents like standard, solvents, reagents, etc. used in analysis are not of desired quality and purity, the result will be obtained with errors, because the quality is must in the experiments. The quality and the purity is essential for an experiment. Fifth one, procedure. If analytic procedure used in analysis is not validated, and if validated but not followed carefully, the errors in the result will be obtained, because following the analytical procedure is must while performing an experiment. Now let's discuss about the types of error. Errors that may be broadly divided into two heads, that is determinate error, it is also known as systematic error. Second one is indeterminate error, which is also known as random error. Let's discuss about determinate or systematic error. Systematic errors are errors which have a definite value with a reasonable cause, and it is also known as avoidable error. These avoidable errors may be measured and accounted for rectification. It is subject to rectification. When broadly see through the systematic error, the sources it covers are personal error. These personal errors are exclusively caused due to personal equation of an analyst and do not due to either on the prescribed procedure or methodology involved. Second one is instrumental error. These are invariably caused due to faulty and uncalibrated experiments such as pH meters, UV spectrophotometers, potentiometers, etc. And the third one is reagent errors. These errors that are solely introduced by the virtue of the individual reagents. For example, impurities inherently present in reagents, high temperature volatilization of platinum, unwanted introduction of foreign substances caused by the action of reagents on either porcelain or glass apparatus. And the fourth one is constant errors. These are observed to be rather independent of the magnitude of the measured amount and turn out to be relatively less significant as the magnitude enhances. Next, the second type of error is indeterminate or random error. As the name suggests, indeterminate errors cannot be pinpointed to any specific well-defined reasons. These errors are mostly random in nature and ultimately give rise to high as well as low results with equal probability. They can neither be corrected nor eliminated and therefore from the ultimate limitation on the specific instruments.